Alright guys, this is Mr. Q, and I'm here at Costco here with our tech Javier, and we're here at the tire shop, and he's going to show us how to balance out a tire, because this is really going to apply to what we do today in our equations lesson. Alright, so let's follow him so he can show us how the machine works, okay? Alright.
Okay. Watch step.
Uh-huh.
Go ahead.
So here's the shop where they load the tires. Sometimes you guys never see in here. So here he has the machine to balance out the tire. So can you tell us,
No weight.
with no weight, so can you tell us the purpose of balancing a tire?
The purpose of balancing a tire is to prevent any vibration, any shakiness at high speeds.
So would you say that it's very important to have the tire balanced so that it can have a smooth ride, so it can be flat, right? Like a nice even ride, Okay.
Yes.
So,
any unbalancing on the tire from roughly about maybe 40 to 60 miles
Okay.
will cause shaking, vibration.
okay.
Lack of uneven wear on your tires.
Okay. And how does the machine work? Can you make it balance this one out and see how that works out?
So what we're gonna do right here is this rim that we have. It's an alloy wheel,
Mm-hmm.
so it actually kind of difference out the balancing on it. The balancing that you're gonna use grams and ounces.
Okay.
So what we do here first.
Ooh, grams and ounces. Let's go.
Okay, so we have this laser
Mm-hmm.
that measures the inside of the rim.
Okay. The laser measures the inside of the rim. Okay.
What we're doing is we're going to measure the outside rim lip. The rim lip right here. And then we're
Okay.
going to measure the inside of the rim lip.
Okay. So that laser measures the outside and the inside.
It kind of gives you a round off of how wide the rim is.
Oh, cool. And here it gives us specs. Check this out.
Yeah, so it's kind of
That's
off
cool.
a little bit. It's kind of off a little bit because it's
Okay.
not always 100%. So what this states right here, this is the rim width, the rim height,
Uh-huh.
16.5, and see it's actually a 17-inch wheel,
Okay.
so it's actually off a little bit.
So just a little bit off, but
So
it's
that's why we have right here.
so they add or take away so it can be the actual size.
So then we go to set and we check the rim width. The rim width
So the rim width.
tells you from 3 to 13. That's how usually that's the width. That's how wide the
Okay.
rim is on your vehicle.
Okay. So from 3 to 13
And this one is actually an 8.
and 8.
So
Okay.
this rim is a 17 by 8.
17 by 8. Okay. Okay.
So we're all set now.
So he sets the machine.
Now we're gonna put it down so it can get the spin.
He closes that so they can start spinning.
As soon as it stops, it's going to let us know where we need to add weight to get the proper balance.
Okay. So right there it stopped,
Where it stops,
and then it's saying
exactly where it stops at.
where it stops. That's
We
exactly.
have an imaginary arrow on this. We should have.
So
a
the bar is your arrow.
bar is our imaginary arrow, and where it's actually on the circle, the red. That's
Okay.
where it wants us to
Put the counterweight.
place the weight.
Okay. So then the weights, if you notice, guys, they have here like a lot of weights here and a lot of
We
weights
have
over
ounces.
here.
We have grams.
So then it tells them there which one to place.
Okay, so on the inside of the rim, we're going to place a 25.
A 25, which it says it right there on the left side of the
25
screen.
ounce weight.
So 25 ounce weight. Okay.
And then we're going to spin it again.
So then they're going to spin it again.
It's going to let us. It's going to stop us.
So it's going
we
to stop
have
for the outside,
we have that.
so it can balance out.
Let me get a rag really quick to
Okay.
clean it up a little bit.
All right.
On the inside, we're going to put 75.
So So then he goes to 75.
And we're going to put it also on the inside. It actually has a line where it actually tells us where it asks for weights.
Okay.
So now we're going to put it down. And it might ask us for more weights. It might ask us for less.
Okay.
It might ask us to move them left or right.
Okay.
Right now we'll know. And it might just zero up.
Excellent. So right there it's zeroed up. So check this out, guys. Now it's totally balanced. So
Totally balanced.
one side is equal to the other side, and they stop it. So
And if you look, the weights aren't always going to be on exactly the
right.
side, in or out.
All right, Javier. Well, thank you very much, and the kids, thank you for helping us with this exhibition.
Sure thing, no problem, sir.
All right, thank you.
Thank you.
Bye. All right, guys. So as you can see, that's how you balance out a tire, and it's very important that you balance out not only tires, but in life, there's things you got to balance out in order for everything to run smoothly. So let me finish shopping because I got some chicken and stuff to get to, and then we'll get started with the lesson in a little bit. All right? All right. Bam. Let's go. At the scale, equations come from that. And the mathematician saw when he went to purchase whatever he did, he saw the table. Does everybody see the table here from the side? And does everybody see the bar here? As he was walking away, as he was getting farther and farther away from the table, all he could see was the edge of the table and the bar of the scale. And guess what he saw? Does everybody see that? The equal sign. And he said, as long as that bar is balanced, that's what it's going to give us the equation. But with that same thought, check this out. Let me go back one step. Look up. Look at this. He saw, wait a minute. There's nothing here, so that's 0. There's 11 here. Okay. Where was the original bar? The original bar was about right there. Who sees it? Bam. Check this out. Oh, snap. You guys see it? That's why inequalities are not equations. Inequalities is the unbalanced equation. Does that make sense? All right, so with that said, get your Cornell note in front of you. We're going to do a quick intro. And like I said, this is more of a review, but I want to give you some processes for you to follow in regards to this lesson. So our objective for today, I can solve and graph one variable equations. Read together, 1, 2, 3. I can solve and graph one variable equations. So I already gave you the Fair model field for the concept for today, which is one variable equations. However, look at this question. What's the difference between an expression and a one variable equation? Think about it. What's the difference between an expression and a one variable equation? Don't say it right now. At the end, you're going to answer that in the summary section of the Cornell note. Everybody understand that? Yes. What's the difference between an expression and a one variable equation? So let's see. One variable equations. It says, mathematical statements where two expressions are equal to each other and contain one unknown variable. Here are some examples that I gave you. All right. So with your pen, if you have your pen, and in red, I'm going to underline the key part of the definition. It says, two expressions equal to each other. Two expressions equal to each other. Let's see if it's true. Look at this example. If I go to the left side of the equation, is this an expression? Yes, it's an algebraic expression. Let me go to the right side. Is this an expression? Yes, it's a numerical expression. Are they equal to each other? Is there an equal sign in between? Yes. Let's go to another. Let me go to this one. Is this an algebraic expression? Yes. Is this a numeric expression? Yes. Are they equal to each other? Yes. So according to the definition, all these are examples of one variable equations. Everybody see that? All right. And what is the key part of the definition? Two expressions equal to each other. All right. Let me show you another example. Copy those, please, on your paper. X plus 5 minus 25, 12 greater than x minus 8, x squared plus 5 equals 30, and 4x plus 6 equals to negative 2y. As you're copying those down,
Think about it. If these are one variable equations, why are these not one variable equations? Don't say it out loud. Keep it to yourself. Why are these not? All right. Turn to your neighbor, let them know, please. Raya, why is this one not a one variable equation? Does not have an equal sign. Tell me the name of this. Expression. That is correct. So this is an expression. And we're no longer in expressions. We are in what? Equations. Okay. Pass someone. Daniel Riesgo, why is this one not a one variable equation? Okay, so why not? So what is this? What is this called? Janelle? Inequality. All right. All right, Daniel, pass to someone. Jacob, why is this one not a one variable equation? No, it has one variable. Can you elaborate a little bit more? He said because it has an exponent. Look at these. These have exponents. We just are not indicating it, right? So what can you elaborate more on that? Greater than 1. So technically this is a one variable equation. However, this one has a particular name. Who remembers the name if I was to look at this. If I was to cover this, who remembers the name of this according to the degree? Raya? Quadratic. So this is a quadratic, and now that it has an equal sign, an equation. We're going to get to those pretty soon. And the last one. Pass this to someone, please. Jonathan? Why is this not a one variable equation? It has two different variables. It has an x and a y. Therefore, now that you know why one variable equations are what they are, come up with some hashtags if you were to take that picture and send it out. Hashtag what? Give me at least two. My goodness. All right, hashtag. Yes. Equal sign. Yes. Hashtag first degree. Yes. Hashtag one variable. All right, and you can fill in the rest, right? All right, so let me move on. Steps. You have the steps underneath, right? And it says to solve and graph one variable equations, we're going to simplify each side, isolate the variable, plot your solution, and check your solution. And I want this done on tonight's home plate. All 4 steps. An easy way of remembering this process is like this. Look up. Circle the word simplify for step 1. Step 2, circle the word isolate. Step 3, circle the word plot. And step 4, circle the word check. So 4 easy steps. Simplify, isolate, plot, check. 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 Tell your neighbor what you're going to do tonight. All right, so we got this, yes? Simply fly. Yeah, you're not going to simply fly. All right. All right, let me forward this. And just to clarify, inverse operations, let's see, just to revisit last year's. If you look at this equation, what is the operation here? And the inverse is subtraction. Here is subtraction, the inverse is. And then here we have what? The inverse is division, and here's division, we have multiplication. Okay, we got that clear, all right? So here we go. You're like, already? Yes. Properties that we're going to look at, addition property of equality, that's when we add something to each side, and subtraction property of equality, that's when we subtract something to each side. What if we multiply something to each side? You got to stay with me. Multiplication property of equality. What if we divide each side by something? Division property of equality. All right, copy this down, please. Example 1. Wherever you can fit it. Here goes the process of what I want to see tonight. Oh, my goodness. All right, here we go. Solve the equation and check your answer. Let's do this one together. Some of you already know how to do this in your noodle, right? But this is what I want to see. First of all, just to elaborate and to keep the idea of a balanced scale, I want you to draw a line down the equal sign. Draw a line down the equal sign. There it is. And that's going to give us the idea of keeping it what? Balanced. Look at the side of the variable. Okay. What do we have on this side? We have -3 or -3. In order to isolate the variable, let's see, can we simplify anything else here? No. Can we isolate the variable? Yes. What is the inverse of this? Add 3, and whatever we do to one side, we do to the other, and we're left with y equals 7. So did we simplify? There was nothing to simplify. Did we isolate the variable? Now we're going to what? Plot. So you draw a number line. And we're going to start y equals 7, so we go 1, 2, 3, 4, 5, 6, 7. And then you're going to plot your point. Simplify, isolate, plot. What's next? Check. So you go check. You write your equation, your original, y minus 3 equals 4. But instead of y, what am I going to use? 7. So this is 7 minus 3 equals 4. Is 4 equal to 4? Yes. Very simple? Yes. Let's go to the next one. Here we go. Copy that one. You do that one all 4 steps. Go. Simplify, isolate, plot, check. Simplify, isolate, plot, check. Simplify, isolate, plot, check. Answer, everyone. Hands if you got 6. That is incorrect. T equals 6. 6 is only an expression. T equals 6 is an equation. If you do that in the parte, I'm going to dock you points. Just letting you know ahead of time. Yay. All right, don't copy that one. Let me get to multiplication. Here we go. Copy this one. Example 6. Line down the equal sign. The variable's on this side. What's next to the variable? The 2. What is the operation? Multiplication. What is the inverse? Divide by 2. Divide by 2. 2 divided by 2 is 1. 1 times v is v. What is negative 6 divided by 2? Negative 3. Plot that on the number line. Negative 3. And then you check. Now, tonight's home plate is going to have some of them that you're going to have at the end, x equals 105. Are you going to do 105 tallies? What would you do? Dot, 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 and get to that number and plot your point. Everybody got it? Yep. All right, so for tonight's home plate, you have a play sheet. Give me a second. Home plate for tonight is a play sheet. Only do both sides. Only both sides. There is tutoring. Before you leave, log out of the iPad, and you can leave it there on the desk, and then drop off your progress and Saturday Academy over here with me. Keep your home plate from last night. Have a good one, guys. Enjoy your home play. See you guys tomorrow. Bye.